So with this crossed orderings pattern analysis, you can analyze three-dimensional contingency tables, much like you might do with a log linear type of analysis. So let's return to these personality data. We're looking at the extroversion self and then the extroversion other ratings. But now let's add in this third ordering. Let's just go ahead and use gender for that third ordering. So I'm just double clicking to move things over. Let's go to our define pattern option here. I'm going to magnify all of this. So as we've been doing with past videos, we'll set this up as the expected pattern. But now notice that this box is active and it's labeled male. If I use this little pull down arrow here, I can switch to the female pattern as well, or I can toggle between the male and female pattern using this double-headed arrow here. So notice I have the pattern defined for the males. Now I can quickly just go to the females and set that up also, or I can use this copy option. So if I select copy, it will copy this pattern, and then I can go to the next pattern, next group, and then I can just paste it. And so there you have it. So this is a quick tool if you need to copy and paste a complex pattern. You don't have to keep typing it in or redefining it. So now we have the pattern set up for the males and the females. And again, this is like a three-dimensional pattern. So we have the extroversion self, extroversion other ratings, and then the third dimension, the males and females. So we'll select OK. And let's go ahead and just get a randomization test while we're here and select OK to run it. So it iterates through. Taking the text output window, we can scroll up, see the options we've chosen, our ordering frequency summaries. Then we get the patterns here that comprise the two layers of the pattern that comprise the three-dimensional pattern overall. Then we get our classification results. We have 142 individuals. 70 of those were classified correctly. That's 49.3%. So that's our percent correct classifications index, or our PCC index. So notice we do not get separate PCCs for the males and females. So it's a three-dimensional pattern. So overall, we get a PCC of 49.30. I'll just hit enter here to scroll this up a little bit so we can see it. We have our randomization results here, and our chance value is less than 0.001. So a pretty small chance value. So we might want to then rule out physical chance as an explanation for these data, or this three-dimensional pattern, and then seek a truly causal explanation instead. Now to help clarify what we're doing, let's go to another data set. This is just a little therapy data set that I downloaded from the internet. I can put a link for this in the description to the video. It's a contrived data set. We see we have 500 cases here. If I toggle on the labels, we have three types of therapy, therapy 1, 2, and 3. And then we have positive outcome or negative outcome for the therapy. And then we have males and females. So again, we have three orderings here. We can set up a three-dimensional pattern to test with that crossed orderings analysis. So let's do so. We'll select analyses and pattern analysis and crossed orderings. Let's go to, well, since that data set's on the top, we're taken to that data set, rather it's set up as the data set to analyze. Let's put therapy over as the first ordering, just double clicking here. Outcome is the second ordering. And now let's layer it by gender. So we have a three-dimensional pattern. Let's go to the define pattern option. So let's say our prediction here is that for males, notice we're looking at males here, we expect the therapies to be by and large effective across therapy 1, 2, and 3. All three therapies should be effective, positive outcomes for the males. And then for the females, let's say that for therapy 1, we expect a positive outcome. Therapy 2, we don't think is going to be very effective for the females. We'll put that as a negative outcome overall. And then therapy 3 is a positive outcome. So now notice we have a different pattern for males and females, but again, this is one overall pattern. It's a three-dimensional pattern that we're setting up and analyzing. So let's go ahead and select OK to run it, and we'll select the randomization test and select OK. Takes a little bit of time to iterate through here. We have 500 cases with a three-dimensional pattern. And taken to the text output window, here we see the, again, pattern, layered male and female. And we get, I'm going to scroll down here, I'm ready to scroll down. We get a PCC of 73.20, so 366 out of the 500 were classified correctly. And the randomization test for that, again, gives us a chance value or C value that is quite low, less than 1 in 1,000. The highest PCC that was generated from the randomization test was 70.80. The minimum was 61.80. So not 1 in 1,000 times did we find a PCC of 73.20 or more. So this might then lead us to ruling out physical chance as an explanation for these data, and then lead us to looking for a truly causal explanation for the pattern in the data. So again, you can test these three-dimensional types of contingency tables or patterns in the OOM software.